Today, we will learn more about the periodic table of element. We will understand why Mendeleev was so passionate about making this a periodic table of element, looking at some of the properties of those elements. And even deeper into the atom, we will have also a closer look at another subatomic particle known as the neutron. Starting with what you have seen about the periodic table of element, you've seen that this funny looking table was made up of columns and rows, something like this. Okay. And in the rows, the horizontal rows, it indicated the number of um, energy shells around the nucleus, while the columns indicated the number of valence electrons. Now we're going to look a little bit more into what else can we figure from this periodic table of element. As you know, many rules have exception. I'm just going to mention one, and it's about the element helium, He, located in group 8a. As you know, this group is supposed to be the noble gases, and they're supposed to be super stable with 8 valence electron. But He is the exception. It only has 2 valence electron, yet it has a full shell. Therefore, it is very stable, just like the other noble gases. When we speak of periodicity of properties, we're talking about repeating trends. And this is what has helped Mendeleev put together his table of periodic elements. We especially looked at the chemical and the physical properties in order to make some connections between each of these elements. Chemists use these periodicity to determine how bonds are formed, if they will form, and how reactive certain elements are. Here are some sample periodic properties. The atomic radius, for example. It measures the distance between the center of the nucleus and the outermost shell of an atom. It decreases from left to right in a period and increases down a group. And it's fairly easy to understand as at each group down the same period, you add an extra electron. Adding this extra negative electron creates this pressure to be attracted to the positive nucleus and therefore kind of shortens the length of the radius. By going down a group, it increases, and that's pretty easy to understand as well because at every period you add another level of energy. When it comes to electronegativity, it is used to determine the ability of an atom to form a chemical bond. The property increases from left to right in a period and decreases down a group. Same thing goes for ionization energy, which measures the energy required to remove one electron from an atom. It helps in predicting reactivity and the ability to form chemical bonds. It increases from left to right in a period and decreases down a group. There are other periodic properties that we can find, such as density, boiling point, melting point, and many others. In a nutshell, we just saw a few of these properties, such as ionization energy and electronegativity, and we can see how they increase or decrease in the periods and groups. Same for the atomic radius, and we can think of electron affinity that would increase going upwards in a group and left to right in a period. There are other characteristics such as metallic character and non-metallic characters that make sense that they would be positioned as such, knowing that the metals are mostly located on the left while the non-metals are located on the right of the periodic table. Let's recall some of the subatomic particles that we have studied already. We know that there are protons located in the nucleus of the atom, while the electrons are orbiting around the nucleus in several levels. The protons are positive in charge, while the electrons are negative in charge. There are the same number of protons as electrons, and we know that because we can refer to the atomic number, which is unique and attached to a specific element. As long as you have the same number of proton, you have the same element. And the symbol to represent the atomic number is Z. Now let's have a look at a third, quite common subatomic particle called the neutron. It was discovered by James Chadwick in 1932, so relatively recently. It proved why protons, which are all positively charged, would actually not repel from one another, all being stuck in the same nucleus, and that is because of the neutron that diminishes the repulsion between them. The charge of the neutron, as its name says, is neutral, and this is how we note the neutron. As far as its mass is concerned, it is pretty similar to the one of the protons, which are relatively high, especially when we compare it to the mass of the electron. In summary, the periodic table of element has the look that it has because of the periodicity of certain chemical and physical properties. The neutron, on the other hand, is one of the subatomic particles that has no charge and holds the positive protons together in the nucleus.